Hello everyone. In the last week, we learnt about an unsupervised learning method known as the clustering algorithm. In the k-means clustering algorithm, we group points into clusters on the basis of the idea of distances. So today we are going to be seeing the implementation of the k-means algorithm using orange. But before that, let us have a quick look at the idea of distance between points. Consider these 2 points, 5, 10 and 10, 20. The shortest distance between them is given by this particular straight line. And to calculate the length of the straight line, we can sort of construct a right angle triangle of which the line happens to be the hypotenuse. Now we can use the Pythagoras theorem, which says that the sum of the squares of these two sides has to be the square of this particular side. So if we calculate the length of these two sides, this can be calculated as 10 minus 5, which is 5, and 20 minus 10, which is 10. Now the hypotenuse is given by the root of 10 minus 5 the whole square, which is this value, plus 20 minus 10 the whole square, which is this value. So in this example, the length of this particular side happens to be 11.18, which is nothing but the distance between those 2 points. More generally, we might have 2 points x1, y1 and x2, y2, and on calculating the distance between those two, we get the formula to be root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Note that it is simply the subtraction of x2 minus x1 and then squaring it, and y2 minus y1 and squaring it, and then taking the square root of their sum. So what if the point is in higher dimension? Because so far the points that we saw were of the form x comma y, which is nothing but points in 2 dimension. However, the idea of Euclidean distance calculation remains the same. So if we were to have 2 points, say x1, y1, z1 and x2, y2, z2, the distance between them is still calculated as x2 minus x1 the whole square plus y2 minus y1 the whole square, and now we have the addition of the new dimension giving us z2 minus z1 the whole square. Now let us have a look at this particular example, which we also saw in the live session, where we have the details of 2 students, say Demi and Nash, and their scores in these 7 subjects here. So you were asked a question that said, who is Nash most similar to? So many of you gave the correct answer from the options that were given. But if we were to concretely tell why Demi would be the one who is most similar to Nash, we can calculate the distance between these two. So to calculate the distance between these two, we will again do 9 minus 14 the whole square plus 15 minus 4 the whole square and so on all the way until 8 minus 39 the whole square. This calculation is similar to what we have already seen using x1 minus x2 the whole square plus y1 minus y2 the whole square and so on. And finally, we take the square root. This way we get the value 77.466 in this case, and that happens to be the distance between the scores of Demi and Nash. So now with this, we'll go ahead and see the implementation of k-means algorithm in the next video. Thank you for your time.